Hello, and welcome to a quick mini lesson where we're going to look at systems of equations and use one specific type of system of equations to solve for the point of intersection. Because if you remember in our last lesson, we were looking at points of concurrency, where we were looking at the incenter, circumcenter, and orthocenter, and the point where they cross could be a point that we would want to find. So a system of equations, set of two or more equations that have the same variables and find the same value. Okay, and the importance of this value is the one coordinate point, okay, 1, 3. So x is 1, y is 3. This is the one value that's going to work in both of these equations. If I do 1 plus 3, I get 4, so that checks. And if I do 1 minus 3, I get negative 2, so that one checks. So when we're finding the point of intersection, it is the one point that these two lines have in common. Okay, so today we're going to look at using the substitution method to find that point. Okay, so when we're using the substitution method, what we want to do is we want to look at the two equations, and hopefully one equation is already an x equals or a y equals. Okay, so that's the very first thing that we're looking for. And the second thing is there a quick potential to get a variable all by itself on the other side? So if we look at this situation, we already have an x by itself in the first equation. And what we want to remember is this x and this x are the exact same value at the point of intersection of these two equations. So what we're going to do is we're going to do a substitution or replacement, and we're going to put this equation in place for that x value. Okay, so starting with my blue equation, okay, 2x plus 5y. So 2, I'm going to leave a space where x was, plus 5y equals 3. And what I'm going to do is I'm going to insert an equation that is equal to x. And then now we need to finally finish up. Okay, we want to distribute the 2, 6y plus 14 plus 5y equals 3. And now we're going to work through and solve for that y value. I need to combine like terms on the left-hand side. I've got 11y plus 14 equals 3. Now I need to subtract 14 from both sides because I want my variable on one side and I want the numbers on the other. So I have 11y equals a negative 11. And then our last step is dividing by the coefficient value, and we get y equals negative 1. Okay, now this isn't a finished answer. This is part of the answer. Okay, so I know what y equals, and then I'm going to pick hopefully the easiest equation to plug that y in and solve for x. Okay, so the easiest equation for me to use is the first one to solve for x. Okay, so I'm going to plug in there x equals 3 times negative 1, okay, substituting that value, plus 7. X equals negative 3 plus 7, x equals 4. So now I have the two parts of my point of intersection. Now, what I want to do is I don't want to stop here, especially if it's a test. If you're doing this problem on a test, you always want to go one step further, and you're going to take this coordinate point, x equals 4, y equals negative 1. So 4 comma negative 1, and I'm going to insert that into my second equation and check and see if it works out right. So 2 times 4 plus 5 times -1, does that equal 3? And if I get a correct answer here, I pretty much know that my answer is the right answer. 8 plus -5, does that equal 3? Yes, it does. 8 minus 5 is 3. Okay, so let's look at one more example here. Let's do this one. Okay, so we want to look at one example. This one's fairly simple, but notice neither of these equations are in a simple x equals or y equals form. So what we want to do is pick one, and you can pick either. What I'm going to do is I'm actually going to pick this one, and I'm going to move the y value by adding y to both sides and turn it into an x equals equation. So x equals positive y minus 2. And what I did is I just got rid of a negative value, which is something that we always want to look for when we're doing these situations. Okay, so now I've got my x equals, so I can substitute into my other equation. So I'm going to replace the x with y minus 2 plus y equals 4. Combine like terms, I've got 2y's minus 2 equals 4. Then I have to add 2 to both sides. So you can see these steps are very consistent from one problem to the next. 2y equals 6, and then I divide by 2, y equals 3. Okay, so now once I have my y value, I want to go back and pick one of my two equations. X plus 3 equals 4. Subtract 3 from both sides, and I get x equals 1. Okay, so now I have my answer. But remember, if this is a test, you don't want to stop here. You want to take that answer 1 and 3, and you want to test it in your other equation. 1 minus 3, does that equal -2? Yes, it does. Okay, so that was a couple quick examples of using the substitution method to find a point of intersection. Thanks, and have a good day.